Hi, my name is Saul Montoya. Welcome to this tutorial on numerical modeling of ModelMuse. For this tutorial, you need to download some files that is on GitHub. github.com. You search for Saul Montoya. Oops. And then you find my profile on users. Yep. On repositories, this is the file. Okay, I will send the link here. Please download here, download the zip file and compress it on your computer, because these are the spatial data that we are going to use for this tutorial. Is that okay? If it is that okay, please type yes to. Please write yes to if you understood the whole instructions. Shukran. Yes. Cool. Great. So what did I do? I have already the file. I go with my file explorer. I go to my downloads. I just Control C. I go to Documents, MODFLOW. I create a new file that is. No, I think that just paste this and then I extract here. Okay, cool. I can delete. Now I have this folder that says Modelamiento Regional de Aguas Subterráneas, and then I have inside this folder I have these 4 folders. Is that okay? If it's the same that you have, please type yes 4, yes 2, yes 3, yes 3. Nope. If you have any problem, please type your problem, or if you require more time, please say more time. Okay. I was more like, okay. While you are downloading, because I think that everybody is downloading, please download and uncompress. Everybody is going to open a new ModelMuse. ModelMuse, do you see here ModelMuse? Yeah, everybody is going to open a new ModelMuse project. Oops, sorry. Wait, no, this is not ModelMuse. Sorry, this is Windows giving me anything unuseful. And this is okay. This is ModelMuse. Yep. Cool, Bruno. Bruno, if you're there, please download the. Wait, just one instruction for Bruno. Okay. Bruno, please download the files that are here. Okay, so type yes for if everybody is or have already downloaded. Bruno, please turn off your Bruno. Hi Bruno.
Bruno Vitorino.
Okay. Yeah. Okay. Cool. Bruno, please, your microphone has to be turned off. Okay, great. So please type yes for, yeah, Woo has already downloaded, Jackson has already downloaded. How is Shuka? Have you downloaded? Diane, have you downloaded? Yeah. So in this time we will open a new create a new MODFLOW model. Okay, everybody is going to create a new MODFLOW model next, and in this time we are going to create a grid but from a shapefile. Okay, so we are not going to create, like, we are not going to specify 10 columns, 30 cells or something like that and the number of aquifers. We rather will use a spatial reference to do that. Is that okay? If you have understood this, please type yes 5. Type yes 5. Diane? Cool. Why Diane, I cannot see your comments. Have you typed it already? Okay, cool. Anyway, so everybody please press the no grid button. No grid button, if you see it here, it has an X but it's actually a no grid button. Okay, no grid button. Cool. And now you have ModelMuse but with the no grid option. So actually you don't have any grid on your model. Is that okay? Yep. Okay. Yes. Cool. Now we are going to import a shapefile in order to do first how can I say, if you want to do a model, you have to set up some things of your model. Yep. In this case, we are going to use MODFLOW NWT. Do you see this MODFLOW NWT? If you see that, please type yes 6. Yeah. Cool. But in order to start with MODFLOW NWT, you need to have MODFLOW NWT installed. So go to MODFLOW program locations and check that this space that is below MODFLOW NWT is on white color. If it's that on white color, you are okay, but if it's not on white color, you have to go to this website and download the MODFLOW NDLT and locate it here. Do you have this below the mod? Do you have this space in blue or red? Please type the color that you have this space. Type Wubu, type Diane, type Jackson, type Chuka, white, wow, Diane, Chuka, cool. So Chuka, you are working on that. Cool, yes. Diane, you have it on red or you have it on white? Why? That's great. Cool. Okay, so I can say okay or cancel. That's the same. So we go to model, package and programs. No, model and then MODFLOW to MODFLOW. We select MODFLOW NWT. Okay, just that. So then again we have this option already installed, MODFLOW NWT for our model. Okay, cool. That's a good question, Shuka. Because MODFLOW NDLT is more adequate when you have higher difference on the discretization, and this time we are going to model basins that have more than 1,500 meters in between the basin, the lowest part and the higher part on elevation. That's why, from my experience, I recommend MODFLOW NDLT. It deals better with this topic of high cells, dry cells and wet cells. Is that okay for you, Shuka? Cool, great. Cool, yes. So, yeah, we have already a MODFLOW NDLT. We go to MODFLOW package and programs. On model, go to MODFLOW package and programs. Yes. On MODFLOW package and programs, we say we are working. When you work on MODFLOW NDLT, you have to select the flow package on UPV. Do you see this? UPV upstream weighting package. You have to select this one. Okay, please select this one. If you have any problem, please type it. So we go to where we are. We are in model, MODFLOW package and programs, and in MODFLOW package and programs we are on flow, and then we change from LPF to UPW. Okay, great. On boundary conditions, we are going to specify on MODFLOW conditions. I'm going to specify the recharge option. Yeah, do you see the recharge option? But I'm going to specify the recharge option on the top active cell. Later I will explain you why on top active cell. Then yes, we are going to have dry cells because on the top of the mountains the water table is far from surface, and while it's far from surface, some layers of our model on the top of the mountains will be dry. That's why we have to apply this recharge package on the top active cell, because we need that MODFLOW looks for the first active cells and then apply the recharge on that. Is that okay, Shuka? Cool. So now, okay. When you are working with mountainous regions, on the lowest part the water table will be close to surface, and on the highest part the water table will be far from surface. But in our model, the water on the top of the mountains, when the water table is far from surface, some layers will be dry. Don't worry, I do know. I will explain. I will come back to this topic while we are working on the model. Is that okay? I do know. Yes, no. Type it. Okay, cool. So we are going to apply recharge, then we are going to apply evapotranspiration, and then we are going to apply drainage. These are, well, as the most projects that I work on, these are the main three boundary conditions that I use to model or ModelMuse. Okay, so everybody has recharge, drainage, and evapotranspiration on your model. Please type yes to. Type it. Diane? Cool, Diane. And I don't know, somebody is missing? Why I do have the Jackson? Well, everybody. I don't know. Do you have it? I don't know, Birhandum. Yeah, please activate these ones, please. Okay, and type when you have it activated, type yes. On recharge, please check that you have on the top active cell options. Okay, I don't know, do you have it? Type yes, type no. Cool. Yes, please, it's really important that you answer me, otherwise I cannot follow you. Yeah, okay, cool. Solvers, we are going to, if you have we're going to have to use the Newton solver, but we're going to increase the number of iterations to 150, because it's when you deal with Andean basins, you deal with 150 to 300 iterations, but especially when you are working with NWT, you don't go further than 300 iterations. It becomes really low. Okay, is that okay? Type yes 3. Okay, Jackson, Woo, I don't know. Okay, it's alright. Subsidence, we are not going to have subsidence. We don't have observations, that's why we are not going to use it. Output, no. Surface water routing, no. This is especially when you want to assess the drainage that come, I mean the water, the groundwater that reach a drainage network, and then you want to see how this flow will transit through a channel or through a river, then you use this one. We are not going to have modpad, neither not some budget. Okay, and then this one, the last one, empty 3DMS, is when you have transport contaminant transport modeling. That is not our case. Okay, so everybody put okay. Okay, cool. So you have already made your package and programs. Yeah, you have already opened, you have already defined the solver, and you have already defined while the solver and the solver and the boundary conditions. Okay, then we are going to have layer groups. Let's go to layer groups. model layer groups. Yep. On layer groups, I am going to define the first aquifer as convertible, the second aquifer as convertible. Okay? Yeah. And the first aquifer, I am going to call it alluvial. And the second aquifer, I will call it upper aquifer. And the third aquifer, lower aquifer. Please insert this. Please change the conditions as you see on my screen and type yes for. Convertible means that the aquifer could be confined or unconfined. It really depends on where the water table is. Is that right, Chuka? Yeah. The first one I changed to alluvial. The second one I changed it to upper aquifer, and the lower one I changed just the name to lower aquifer. The middle one, no, it's really up to you to ask to define just 2 aquifers or 3 aquifers or 4 aquifers. Is that okay, Diane? Okay, cool. Cool. Then we say, okay, I have a bag. And I will say just continue the application. Why I have a bug? Because I don't have any I don't have any grid right now. Okay, so I'm going to import the shapefile. Okay, everybody go to file, import shapefile. Here on file, import shapefile. And on the folder I gave you, there is a folder that says shape. And there is one that says Geología de Zona. Yeah, I don't know if you find an error, just press the continue button. Don't worry. Yeah. So you have here Geología Zona. Okay, you have it. Cool. We are going to open it. Just say 2 clicks and then we open. If you have the same that I have on my computer, please type yes 5. Diana. Okay. Cool. I don't know. Yeah. And here you can see, yeah, set value of enclosed cells. We say set value of enclosed cells true and nothing else. It will open, wow, many objects. Cool. Just say import shape and enclosed. Put OK. Nothing will happen. Well, it will. Well, nothing will happen because actually, if you go to this, close to the E, says show or hide objects. here show or hide objects, you will see, cool, sorry, it's my fault, we have imported the geology, but we have not imported the basins, while what we need are the basins. Sorry, was my mistake. Okay, sorry. So we go to File, Import Shapefile, and then we go to, where we go? Cuencas Raster, and then we go to Cuencas Raster Cut. Yeah, don't worry, Shuka, because we are doing once again. So because it was not the right file. So what we have to do is File, Import Shapefile, and then we have to go to Shape. We have to go to Cuencas, is in Spanish as basins, Cuencas Raster, and then we'll see Cuencas Raster Cut. Okay. And here we say set value of enclosed cells. And then we put OK. Everybody that is here type yes 6. Cool. You are a great group. Yep. And then go to here. Do you see this one here? Where my mouse pointer is? It says, it looks like USB icon, and actually gave you this show or hide objects. If you see that, please type yes 7. Yeah, it's here. Okay, Shuka, if you have problem, go to object and look for show or hide object. It's the same option. And if you don't have, Control Alt O. Okay. Now we have Cuencas Raster Cut 1, 2, 3, 4, 5, 11. In this case, we are not going to use or to set the whole basins. We are going just to set one basin. Okay. So first, let's say that let me have a look. Yeah, we are going to use, please go to Cuencas Raster Cut number 8. Everybody go to Cuencas Raster Cut number 8. Make it, do it double click, and then you will have this option. Please, if you have this option, type yes 9. Type yes 9. Please type it. Okay, so here we are going to define that this basin will be used to define the grid cell size. Yeah. Okay. Here there is already some attributes regarding to the basins. This says that the basin has already 68 million of square meter. Yeah. And if you do some calculations, 68 divided by 200 divided by 200. Yeah, we need our grid cell size of 500 meters because our basin will be too high. I mean, if you have a lot of cells on your layer, sure, you will have a better understanding of what is going on. But the other problem of this is that you will have a better understanding, but the model will be higher, will weight more, you will compute it in more time, and it will be not so easy to handle. So that's why our cell size for this time is the appropriate to define a regional model. Okay, but if you have a model that is for example for infrastructure, or like on a local place, will be 200, maybe 20 meters. 200 by 200 is the number of cells, yeah, but in this time it will be 500. Okay, so everybody say 500. Are you there? Yes, 500. Okay, it's very important, and this is my point of view, to give it colors. Just give colors, because otherwise everything in ModelMuse is black and white. Okay, so you cannot select which was actually the object that you have selected. So please give any color. Okay, you just press here and then you select the color. Okay, if you are there, just say okay. So you just set this to 500, you change the color, and just say okay. Cool. So everybody see this icon that say generate grid, or like go to grid, and then you find the first one that says generate grid. Please go and press generate grid, and then you have this window. If you have this window, please type yes to. Okay, if you say some basins are not, it's not optimal to use it to define them as horizontal and vertical, because sometimes the basins have a preferred axis on a north direction. So we let the model to decide which is the grid angle. Okay, so that's why we say generate grid angle automatically, and we press OK. Okay, and then here we have our basin. Do you see our basin? Do you see our basin? Please type yes 3. Cool. Yes. For example, in my view, maybe the basin is like we need to 500 meters could be very coarse, no? You see that we have really few elements on our basin. Is that right? I think so. Okay, so we are going to increase the number of cells from 500. I'm going to decrease the cell size from 500 to 150. Yeah, this is really easy. Just do this. Go here, just do double click to the object, and then just change this 500 to 150. Yep, and then nothing happens because you have go to grid and then generate grid, and then you just press OK, and here you have it. You have the basin, but with a better resolution. Like you have the grid, the cell size that is actually you have the cell size that is actually has more resolution. Okay, cool. I'm going to explain you something cool and something very useful from selecting objects. Here, since we have imported the geology, this time we are not going to apply geology. Okay, so we have to delete all these objects because actually for us is unuseful. Okay, so we go to this, we do a zoom out. You can do it with just pressing this. We go to the red arrow and just select. For example, I select these ones and I wait, and I have already selected, and then I press delete. I have already deleted these objects, and I delete all objects that are outside of my model area. And there are some objects that do not delete. I can select it one by one. There is no problem. There are not so many. I do that because we have to work with the object data list, and these unuseful objects actually do not give anything right now to our model. Okay, so now I have just my grid and my basin. Shuka, any question? If you have not working, don't worry. Okay, let's say I can do Control Z. It seems that they erase, but it's actually are complementary polygons. So it doesn't stay, it stays the polygon that is inside the other polygon. That's why. So you have it. It seems that they stay, but you need to do it twice, because you have to delete the outer polygon and then you have to delete the inner polygon. Is that right, Shuka? If everybody is here, please type yes for. Jackson, woo woo. Okay, woo woo, hurry up. Shuka, how are you? Okay, you will get used to this because actually you delete a lot of here. Okay, cool. Now we have the polygon, and then we have here the three layers, but what we need is that we are working on a basin, and if we are working on a basin, the active part of our basin will be just the inner part here, and outside the basin will be inactive. Is that true? I think yes. Okay, so what we are going to do is that we are going to define that only this part will be active and the other part will be inactive. Okay, Shuka and Woo Woo, are you okay? Please type yes for. Woo Woo. Yes, okay, great. So everybody go with the red arrow to the polygon, give it double click. Cool, double click. And here in number of set formulas, let's change from 0 to 2. Okay, from 0 to 2. And it will go to model top. Model top is actually surface. 2 on the lower set coordinate will be edit function. Okay. Okay, here. Okay, again. Here please select the basin. Okay, the basin that you have colored, just select it. Okay, and then do double click, and then this appears. If you have this, please type yes 5. I don't know. Cool. And here you're going to change the number of set formulas from 0 to 2. And this is a warning. This is not a hero. This is actually a warning. And warning is just something that you have to take into account. But it doesn't mean that you have done it wrong. Okay, please. If you have done it wrong, it will say error. But a warning is not, is something, is more like a feedback, something like that. Okay, and this applies for every stage of the model, because many times you have warnings, but you have to know what is the warning is about. Model top, and here in lower set coordinate we go to edit functions, data sets required, layer definition, and then we are going to select the lower aquifer bottom. Lower aquifer bottom, we do double click to lower the aquifer bottom and automatically it will appear here and it will appear here. If it appears here, it means that the model have compiled that this one this one will be lower aquifer bottom. We say okay, and then you have model top to lower aquifer bottom. If you have it right like this, please type yes 2. Cool. Jackson, what's the problem? I don't know. No, you have to select. data sets require layer definition, and then you have to select this one. You double click here, and then it will appear here, lower aquifer bottom. Then you press OK, and then this one will be regenerated. Is that okay? I don't know. Okay, cool. Okay. No, don't press OK. Okay. Go to data sets. On required hydrology, here on active, you are going to say that this part that goes from the top to the bottom and only on the basin is the active part of the basin. Okay, so it's true. Yeah, and then you press OK. So here on properties, you just go to model top to lower aquifer bottom, and on this part on datasets required hydrology active, true. True is true with capital T. Okay, this is very important, because if you put true with minor t, it won't work. Okay, so nothing had happened, because actually the part that is outside the basin is also active. So we are going to define that the part that is outside the basin will be inactive. Okay, how do we do that? We go to edit. No, we go to data, edit datasets, data, edit datasets. If you are seeing the same as me, please type yes 3. Okay. Here hydrology, here inactive, we are going to say false, because we know that outside our basin is actually not active. So inactive, we say false, say not active. Okay, apply, close. And nothing has happened? No. Now something has happened, because if we go here below these zooms, it says show or hide 2D grid lines, and then we say show active. Active is just what is inside the basin. Okay, if you see what I am seeing, please type yes 4. Here show active. Do you see that? Is that right, Shuka? Okay. Okay, how we inactivate the other cells is a good question here. Here in data, edit data sets, these ones require hydrology. Here, when we say false here, is that actually by default everything will be inactive, and since we have inserted an object of the basin will be active. Did you understood that, Shuka? Okay, cool. So we go to, with this one, with this cross, we can go to any part of our basin to see. But since we have not imported any topography, nothing is, you are not seeing that, everything is flat, but it actually there is a topography. Okay, the next part is that we are going to define that our alluvial will be of 15 meters, our upper aquifer will be of 50 meters, and our lower aquifer will be of 100 meters. Okay? Tick. Okay, so we go to data, edit datasets. Data, edit datasets. On data, edit datasets, on required, layer definition, model top is surface, don't worry. Upper aquifer bottom, that is, okay. Here should be, okay. I see what I did. It's only for me. I didn't make the change. I didn't apply here, okay? That's why I was seeing. Wait. I told you this is alluvial and this is upper aquifer, and the first one and the second one will be convertible and the third one will be confined, and then I press OK. Cool. And then if I go here to data, edit datasets, okay, it's a good time to save your model. Please save your model. Go to file, save, file, save, and on the folder that we gave you, there is a carpet, that's a folder that says models. Here you just say tutorial 1, and then you can write it as a GPT. It's okay. Save. Now you have saved your model. If you have saved your model, it appears here tutorial 1 GPT. No? Here on the top part it appears the route of the model. Okay, cool. And okay, cool. This is alluvial. Okay. Okay. I think I cannot alluvial. I don't know why I cannot change one. Alluvial. This one will be upper. But somehow I won't put any space in between. Okay, cool. I go to data, edit datasets. On required layer definition, here I have model top, alluvial bottom, upper aquifer bottom, and lower aquifer bottom. If you have the same as me, please. Where I do change this here in MODFLOW layer groups. If you have the same as me, please type yes 6. Okay, Wubu, I don't know, Chuka, Diane have already wrote, I guess. Okay, cool, cool. Yeah, because Shuka, have you already? Yeah, what was the problem, Shuka? I had the same one. Because you cannot repeat the number, the name. So upper aquifer on the original, if you type it like upper space aquifer, it's an original name, and then on ModelMuse you cannot repeat names. So that's why it doesn't make the change. But when you put upper aquifer or you put just any other aquifer name, it made the change. Have you understood that, Shuka? Cool. Cool. Yeah. So on model top, we have model top, and on alluvial bottom we have that this is an altitude of -10. But actually, we are going to relate the alluvial bottom to the surface, because what we said is that the surface that the alluvial will be 15 meters thick. Yeah, and it doesn't matter where the surface is, you will have an alluvial of 15 meters thick. Okay, so we go to alluvial. Shuka, how are you? Have you done it? Yes, okay. So we go to alluvial bottom, we select alluvial bottom, and then we go to edit formula. On edit formula, we say that the bottom elevation of the alluvial is model top minus 15. Model top minus 15. I will do it again. I go to edit formula and I press model top twice and it will appear here minus 15. Then I say OK. And then I say the upper aquifer bottom is actually 50 meters thick. So it's actually model top minus 65, because it's 15 of alluvial and 50 meters of the... I can relate it to alluvial or I can relate it to model top. In our case, we will relate to model top. So upper aquifer bottom will be model top minus 65. Okay. And lower aquifer bottom will be edit formula model top minus 165, because we have said that the first aquifer is of 50 meters thick and the second aquifer is of 100 meters thick. Okay, so everybody, model top minus 15, model top minus 65, and model top minus 165. If everybody is there, please type J7. Shuka, Wubu, Tayan. Cool, you're doing great. Then we go to apply. If you apply close, nothing will happen. You have to do it, you have to press apply. Okay? And then once you have done apply, you put it close. And what you will have? You will have already on your cross section a model where the first layer is 15, the second layer is 50 meters, and the third layer is 100 meters. You can measure it. This one is 100 meters, this one is 50 meters, and the other one is 50 meters. Please measure it, and once you have measured, please type yes to. If you have any question, please let me know. you can measure with this one. Close with this. There is a ruler that is. The grid do not appear. Yeah, maybe you're seeing something like this. Okay, you have to change the center, I mean the cross section with these ones to the center of the grid, and then it will appear. Is that right, woo woo? Woo woo, are you okay? Okay, go to this cross. Do you see this cross, blue and green? And then once you have it pressed, go to the center of the polygon, and then you will see the cross section. Is that right, woo woo? Okay, cool. Now our layer thickness is related only to the surface. Now we can import surface. Okay, so what we are going to do is to import the surface. But first, and this is a good practice, save your model. Save it. Okay, and then go to File, Import, Surface Grid File. Everybody, File, Import, Surface Grid Files, and here on rasters, okay, sorry. Okay. Go to your File Explorer, and here where you have rasters, I have compressed the surface grid file because it was too heavy. So you have to extract here. You have to uncompress this one. Yeah. And then you have this AsterDEM.grd. Okay. So first go to the folder we gave you, and then go to the rasters and uncompress this one, this point rar, that is a compress. This is a compressed file, and then uncompress it, and then we can import it. I have to compress it because it didn't allow me to upload. Okay, so we go to File, Import, shapefile. No, sorry, it's not shapefile. File, Import, surface grid file, and then we go to rasters, and then here is our GRD. If you are seeing what I'm seeing, please type yes 3. I don't know. Shuka and Diane. Okay, cool. Now import it, and then you will see very interesting information. First, you can see the extent of the raster, and which is the minimum elevation of the raster, and which is the maximum elevation of the raster. If you see, well, you cannot see very well, but the raster is huge comparing to the extension of the model. So you will use a part of the extension of the model. Okay. Okay, cool. First, and then I will first look at the filter method. Do you see the filter method? If you see the filter method, type yes for. No? No? Okay, for I don't know, I will do it once again. Please read the filter method for the rest ones, and then I don't know, I will. File, import, surface grid file. You go to here because you have already uncompressed this one, because actually it was this but with extension rar, and then you uncompress it, and then you have with the GRD, and then you put open, and then here you see the filter method. Is that right? I don't know. And the other ones, please look at the filter methods. What do those filter methods say? Yeah, the first one is actually you please remind me, please write which is the cell extension. Type it from your memory. How many meters has the cell extension, the cell size? Which is the cell size on average? Jackson, Ugu. Okay, cool. Shuka is 150, and then we are doing a model that has one that a raster shapefile has a raster AsterDEM has a raster resolution of 30 meters. So imagine how many points of the raster of the AsterDEM we will have in one cell of our model. 25, is that right? We will have 25 points defining elevation in only one cell, and this filter method is the one that helps us to select which will be our filter, because actually we just need one elevation per cell. So we can do the average or the point closest to cell center. For me, point closest to cell center works okay. Okay, so just type point closest to cell center, and this one will be directly set to model top. Okay, and here set value of intersected cells. Okay, so please set model top, set value of intersected cells plus point closest to cell center. Okay, and then press OK. And wait. Here you can see our model, yeah, where every layer is located, where you have one layer that is the aquifer, the alluvial, the first aquifer and second aquifer. Something to remember is that we might, first of all, we are going to decrease the vertical exaggeration because it's too exaggerated. So we go to view vertical exaggeration, and then we put it we have to put it 3, and here we have but for us 209. Okay, we are going to go to data, edit data sets, required layer definition, and the lower aquifer bottom will be not defined by a formula, but rather defined by 200 by elevation, 2900. I will repeat it. We go to data, edit data sets, we go to required layer definition, and the lower aquifer bottom will be defined by 2900. Okay, because in order to fill this, because otherwise we have a really, I mean, comparing with the elevation, is very thin our aquifer, and then with this we have it like more, has a better shape. Do you see? If you have the same as me, please type yes too. Boo boo, I don't know. No? Okay. Data, edit data sets, required layer definition, lower aquifer bottom, type 2900. Boo boo. Okay, yeah, cool. You are doing great. Now we have the geometry, we have opened the boundary conditions, but what we haven't applied the boundary conditions. Okay, cool. Do you understand me? Okay, cool. So what we are going to do right now is we are going to import the rivers as drains. Okay, so we go to File, Import, Shapefile. File, Import, Shapefile. And on the folder that we gave you, Shapefile, we have channels cut. You have channels cut. No? Again, File, Import, Shapefile, and then here on the folder that we gave you, we have shape, and then we have channels cut. We open, and here is really important that the import shape as single multipart object, otherwise you will have your directory filled with parts. If you import shapefile as a single multipart object, yes, and set value of intersected cells. Only this, set value of intersected cells and single multipart object. If you are here, please type yes 3. Okay, cool. And now is importing, and this is the whole water network, but we do we need all of this? Do we need it? No, we need just what is for here. We don't need the rivers that are outside the basins. Okay, what we are going to do is we are going to select the basins and everything is just one. It's only one element, but we are going to delete vertex. With these ones, if you see, if you have selected close next to the red arrow, there is one that is the vertex with the square, with the black square, and then with this one you can delete vertex. First you select, and with this you can delete vertex. Okay, some of them appears white, and then you press delete. And you have to wait because it's not so. And then again, and then again. And please delete all the vertex that are not on your So then I have only vertex that are on my network. If you have the same as me, please type yes for. No? Okay. If you need more time, please type more time. Yeah. Okay. While you are deleting, the next part we unselected by just pressing the red arrow outside. We have to apply this. We have to apply this element, this water network, as a drain boundary condition. Okay. If you remember, we have the drainage, recharge, and evapotranspiration. Okay, so what we are going to do now is to apply them. Okay, I don't know, Jackson, you delete with these ones, with this, not with the, you don't delete with the, you select the vertex, you have to select the vertex with this one. I don't know, Jackson, how are you doing? Type please. Okay, now I don't know. Okay, cool. Yeah, go and select the river, select it, select the river with the right arrow, and then we are going to say number of set formulas 1, and the number of set formulas 1 will be on model top, because actually our river or our drainage network is on model top. Okay, cool. Model top. Number of set formulas 1. Okay, we change the always change color. Yeah, we change the color. Okay, we see the color, then we apply number of set formulas of 1. If everybody is here, please type yes for. Cool. And then go to MODFLOW features and apply and go to drain. Select drain. Okay, here in MODFLOW features, select drain. Okay, while you have selected drain, you have to select the starting time, that is actually -1 to 0 because we are running in steady state. The elevation is model top, and the conductance will be the conductance interpretation by direct, and this one will be 0.001. Okay, cool. If everybody has a question, please type it. If you are okay, please type yes 5. This is a good question. How do we obtain the conductance? I really recommend you to go to the papers. Actually, I don't know if you have been in our former the value of the conductance, how the conductance is interacting with other ones is already written, and there is a lot of information. I will give you. We gave you no, I have written learn MODFLOW with ModelMuse, and I have written to learn MODFLOW with ModelMuse, but on Hatariwater. Okay, cool. You have to read, my friend. I'm not going to tell you that it will be simpler. You have to read a lot, and then you will define and see how this value, where this value come from, and what it actually mean. And this is the knowledge of MODFLOW is of people that have done projects, and also people that have read a lot. Okay, cool. Okay, so if everybody is here, type yes 5. Diane, Wubu, I don't know, Jackson. Okay, Jackson, Wubu, 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 Wubu. Is there Wubu? Okay, cool. We said okay. Okay, now we have already our boundary conditions are already set up, and then we have to insert two things: the recharge and the evapotranspiration. A charge and evapotranspiration can be inserted in just one, can be inserted in only one element, yeah, because actually recharge will apply when you have the water table below surface, and evapotranspiration will be applied when you have the water table close to surface. So actually you cannot have a cell that have recharge and evapotranspiration, whether it has recharge or it has evapotranspiration, but you don't have to worry about it because MODFLOW will look for that. Okay, if you have understood this, please type yes 6. If you have understood what I have said, please type yes 6. Woo woo, where are you, boo boo? Okay, great. Okay, so here I'm going to create a rectangle object. Create a rectangle. It's good time to save your model. Save your model. Save. Yeah. And then with this one, we are going to make a rectangle that goes from, oops, saving. I don't know why it's so. I have to let the model to be saved. Okay, cool. And then I just create a rectangle by pressing and keep, no, I press once the button, and then I create a rectangle that fills all my basins, that covers all my basins, and then I just do another click here. Okay, if the rectangle that you have selected is not right, just type escape and then do it again. Okay, if you are where I am, please type yes 7. Please type yes 7 if you are where I am, if you have the same that I have. Type it. Cool, Jackson. Diane? Okay, cool. Now, okay, these ones will have 0 formulas because it's actually the recharge and evapotranspiration. 0 formulas. Yeah, this one will be recharge and evapotranspiration. Cool, that's great. And then number of formulas zero, change color, always change color. Cool. And then go to MODFLOW features. Okay, first you change the name, then you apply color, then you put the number of formulas set as 0. Okay, and then you go to MODFLOW features. On MODFLOW features, you type evapotranspiration. From -1 to 0, the evapotranspiration rate will be 1,200 millimeters per year. So it will be 1.2 divided by the number of seconds per day divided by the numbers of days. Okay, because actually the rates of evapotranspiration and the rates of recharge and any rate in ModelMuse is on meters per second. Yeah, And don't worry if your value is 3.8 times to 10 to the minus 8. Is actually MODFLOW works with these values. If you are seeing what I am seeing, please type yes 2. If you have any question, please write. Jackson, Gubu, I don't know. Yes, I don't know. Gubu. Okay, so yeah. Woo. Yeah. Okay, evapotranspiration surface is model top, and evapotranspiration depth is actually related with the routing depth, and is actually 0.5. Okay. Okay, so if everybody is here, please type yes 3 in order to define the recharge condition. Diane? Cool. Now we go to recharge. On recharge, the starting time is -1, ending time is 0, and the recharge rate will be 150 millimeters per year, so it's actually 0.15 meters divided by the number of seconds per day divided by the numbers of days per year. Okay? Okay, so if everybody is here, please type yes 4 in order that we have just to define 2 more parameters in order to make our model run. Okay, so please type yes 4. Diane? Cool. Now we have to define 2 more parameters. First one are the initial heads, and the second ones will be the first one will be the initial heads, and the second one will be that we have to define a hydraulic conductivity to our model. And this time we are not going to define a hydraulic conductivity layer per layer, yeah, because actually I have to run a little bit, but we are going to define by default the hydraulic conductivity of is 1 to the 10 to the minus 4. That is pretty high for fractured aquifers. So what we will need is to decrease this value. Okay, so everybody go to data, edit datasets, required hydrology, MODFLOW initial head. Everybody goes to MODFLOW initial head, and on initial head, this is the first value that the model requires to iterate. So we go to edit formula and we select model top. So this is not a value that will, I mean, the model requires this value in order to iterate to get the solution. So we need to define this as a model top. Okay, if everybody is here, type yes 5. If anybody wants more explanation, type it. Cool, you are doing great. I'm very happy with you, so I can think about doing more hard stuff. On model top, no, okay, initial head is model top, is that right? And then on kx, we are going to define, instead of setting 110 to the minus 4, 110 to the minus 4, we're going to say 110 to the minus 6. Yeah, that is the value for a fractured sandstone. Okay, everybody? Yes? Okay, apply, close. Save your model. Save it. And run it. You can run it. Now you have all the parameters to run the model. So you can just press this green arrow here that says run MODFLOW NWT. It will create a name. Please do not change these names. Some people change it, but it always, since one connects to the other one, it always makes some problems. Please do not change. And it start compiling. It gives some warnings. Oh wow, I have a problem. Which is my problem? I have a problem that I have, but my problem is that I will close this and it will give me a file like this. Which is my problem? Recharge. Yes, I know which is the problem. Okay. Yeah. Okay, cool. We have a problem. Errors and warnings. We have only warnings. We don't have errors. So this is not the problem. The problem is that actually our model has a very low hydraulic conductivity on top. Yep. And we have to, and we know that on top we have whether alluvial, aquifer, or whether rock. And this is important. So we go to data, edit datasets, required hydrology kx, and here we are going to define a formula that for our first layer we will have a higher hydraulic conductivity, the second layer will be a medium, and the third layer or the lower aquifer will be a low hydraulic conductivity. Yep, so everybody will come data, edit datasets, required hydrology kx, edit formula, and here we are going to apply one of the many functionalities of ModelMuse, that's a logical case layer. Entonces, if that is a case is a multiple if layer is number 1, we'll have 10 to the minus 4. If case is if layer is number 2, 1/2 10 to the minus 5, and if case is number 3, 1/10 to the minus 6. This is actually, and you can, if you get lost, just copy paste this because it's actually recognized, and since it appears here, Is this, I mean, once it appears here, is that is actually understood by MODFLOW. Yeah, and this is by setting this, you are applying higher hydraulic conductivity to the top and lower to the bottom. We put apply and close, and then we run it again. Let's see if it works. Cool, it worked. Hey. It works, my friends. It's really interesting. If you are here like me, please type yes 6. Yes 6. If you are seeing what I'm seeing. Jackson. Diane. Cool. So now this is the list file, the one that appears here, and here we have that the recharge is the only input. I am in at the bottom of the file. The only input is recharge. Okay, that's cool. But it will go as evapotranspiration as drainage. This is actually cubic meters per second, so it's 327 liters that goes mostly as drainage, and some part goes as evapotranspiration. Okay, cool. And now we are going to import heads. In order to import the heads, we go to here. Do you see this one? Import and display model results. Okay. And then you are going to open not the FDM, but rather than the FHD. The FHD is the heads. And then you just have your steady state. That means that only you have this one, and then you are going to import as contour grid, not as color grid, contour grid. So here and here. Okay. And here you have the contour grid. Maybe it might be that you are missing something. Like you really need more layers. Yep, that we can do it. I mean, you can define more layers by going to layer groups, and to a local aquifer maybe put 7, something like that. I do know, please tell me which warning does it give, but I'm not going to put any other layer. Okay, and then okay, I do know, warning is not an error, warning is just a warning. And then go to data visualization. Here you see data visualization, close to the here is data visualization. And here on data visualization we go to cross sections, model results, water table P1S1. Again, cross sections, datasets, optional model results, water table P1S1. And then with this arrow we put it to plot. We select a value. Sorry, what happened? We select it and we put it apply. And that's what is appearing. This is the water table. Since we have applied 110 to the -6, it seems that the model is not creating a huge water mounding, or like the transmissivity is huge. I think this is related to the to the discretization as well, because this layer is very this layer is much thicker than this one, so you need mostly that your layers will be uniform. Okay, cool. So this is the end of the tutorial. So I will end the cast here, but please don't go away, because I want some of your feedback. So this is the end of the tutorial. Thank you for following us. Please follow by our social networks, by our Facebook, by our Twitter, and subscribe to this YouTube channel. Great. And see you in the next tutorial. Bye bye.